Hello everybody, my name is Thomas. I'm going to do a presentation on Kafka Storm for the Big Data Analytics course. So first we'll start with Kafka. Uh, Kafka is a open source distributed messaging system. Uh, it is highly scalable in so that um, depending on the load you can add more nodes. It is fault tolerant, which means that um, everything, multiple copies of all data is stored, and also the messages are persisted on disk. So in case of any failure, if the process crashes, you can start if the process comes back, it will start processing the messages again. um, it's widely used in industry and it has very high throughput, and this can be used in a distributed environment. And the most important thing about a messaging system is whether it can maintain order, because sometimes you need sequential processing and Kafka allows for that. There are mechanisms which can be used to do ordered processing. Now the various I'll give a brief introduction of the components involved. So the terminology is anything which produces messages are called producers. Things which consumes them are called consumer. Um, the Kafka cluster can have multiple machines. A message is published for a particular topic, and so while consuming, the consumer has to uh, subscribe to a particular topic to consume the message. Now now there are some things called partition, and this help in scaling. So I mean, if we know that the topics are similar, or the messages are similar, so they all belong to the same topic, but they don't have to be processed in an ordered way because there is distinct differences between them. Then we can set up within a topic, you can set up the messages in different partition, and each of these partition can individually reside in a single machine. So depending on the size of the machine, that is the limiting factor on the partition. Now the other thing is, like each component, each instance of the Kafka is called a broker. So they all communicate to each other using Zookeeper. So the Zookeeper, the Kafka brokers know about other broker using the data stored in Zookeeper. So when the brokers come up, they negotiate and decide who is the leader for each partition. All the other brokers are called followers, so they just replicate the data, but all read and write happens to a single broker for one partition. So to get high throughput, and if the particular topic has a lot of messages, then uh, partition is a good way to go. So I'll briefly talk about the installation, and I'll also show a brief demo. The installation is fairly simple. Um, so we just have to untar the download, then set up few properties, and if you are installing in a single machine mode, you don't have to set up any property, it just starts immediately. So the first step is to start the Zookeeper, then and the second is to start the Kafka. So if everything is in the default port, then the Kafka installation is usable immediately. So I am using a command line tool to test this Kafka instance. So we can create a topic, and here the important thing to see is there is this thing called replication factor. So since this is a single node cluster, I'm setting it as 1. Then the second command shows how to send a message. So the first first you create a topic, then you submit the message to a particular topic. Then the last example shows how the message can be consumed. Now if we need to install Kafka on a cluster mode, then um, the Zookeeper has to be configured on all members of the cluster. So in the config folder, there is a file called server.properties. So here we can put the broker ID and the Zookeeper information. So once we install on a cluster mode, you can create the topic to be clustered. So in the example I tried, I only had 2 instances of Kafka, so I put the replication factor of 2. So let me briefly show a demo. So I have 2 machines here, and you can see that both the Kafka and Zookeeper instances are running. Okay, so the top one is Zookeeper and the bottom one is Kafka, and let me run a sample command to just to see what topics are available. Okay, so this will describe the my replicated topic. So you can see the replication factor is 2 here, and there is only 1 partition in this. Okay, so let me send some message to this topic of my replicated topic. So the command line utility is very simple. New line is the marker for one message, and control C ends all messages. So let me put some dummy message. Okay, so now we are on the second machine. You can see the IP is different. Now let me run the consumer here. Now I'm going to talk about Apache Storm. Storm is a real-time event processing system. It's also based on open source. It's highly scalable, but it has some similarity to Hadoop. So there is only one master node. It's called Nimbus. So and as we have seen in Hadoop 1, the master data node is a single point of failure. So that has to be installed in HA mode. All the actual work is done by the supervisor, which are the worker node, and so they are highly fault tolerant, and the data is replicated and the state is maintained through Zookeeper. So Storm gives lot of flexibility in terms of what can be done with a stream of data. Various highly complex scenarios can be implemented in Storm. You can do some processing, transform the data, then put it into another bucket, or as it is called Bolt, and then more processing can be done. So various complex scenarios can be implemented using Storm. So to briefly explain the components in Storm, the individual data element is called tuple. The only limitation is it has to be serializable. So anything can be a tuple as long as it is serializable. A series of tuple is called a stream. Sprout is the source of streams. It generates the streams. Bolts are the components which process the stream, and a hierarchy can be made using bolts to do various levels of processing. So I'm showing a simple example of how a topology can be created using a spout and two bolts. So you can see that the top part of the code shows a very simple spout, and what the spout does is it has a list of 5 names, and it randomly sends one name, and the function that is used is emit. Now what the bolt does is, when the bolt receives this message, it appends 3 exclamation to it and re-emits it. Now in the bottom part you can see the topology, and in the topology what we are doing is we are saying that the first bolt receives from the spout called words. Okay, the second bolt in turn receives from a source called exclaim1. So this is how you can chain the events. Okay, so this function is shuffle grouping, and there are various other types of grouping. So I'll briefly explain how the installation can be done. Um, the installation is just involves untarring the storm binary. Then the zookeeper has to be set up in the storm.yaml, and whichever in a multi-cluster node you have to mention which is the master or the nimbus. Okay, I'll show a brief demo. So in the demo I have 2 machines here, and the Storm is already installed and working here. So I just ran a job in Storm. So this is the command to start the Nimbus, this is the command to start the supervisor, and on the other machine I ran the job. So this is the command I have used to submit a jar to Storm and execute it. So you can see the command is very similar to Hadoop MapReduce commands. Now I think this particular topology is already running, so let me just show the debug results. This topology is installed in debug mode, so it prints all the results in the logs. Okay, I see some errors here, so I mean it's possible that I might have run out of memory because little bit limited on memory on my laptop. So we'll briefly talk about Storm Kafka integration. Um, I couldn't complete this part, but I have a good idea on how to do it. So one use case was an alerting system where all enterprise data regarding um, say we are generating alerting system to handle machine failures or application failures, so all relevant data which is say collected every minute can be streamed into Apache Storm, and then the bolts can look at this data and decide whether they need to be escalated or put into somebody's queue. And so that is one use case I can think of. The other use case is like some kind of counting. So whenever lot of events are happening and you want to know what is the occurrence, so all that, so the events can be messages which are exchanged, and whenever a particular event is seen, they can be entered into the stream, and then the stream bolts can do the counting. So thanks for watching.